that, it is my pleasure to again welcome you to today's Hexagon Geospatial Snapshot webcast, Earth, Water, and Fire, Customized Indices using ERDAS Imagine and Spatial Modeler. I would like to introduce your speaker today, Frank Obusek, Applications Engineer. Frank, take it away.
All right, thanks Jessica. Welcome everybody to another Hexagon Snapshot webcast. Today's topic, as Jessica mentioned, we're looking at indices in ERDAS Imagine and how to do some customization with regard to earth applications, water applications, and fire applications. So to get started, let's first do a little refresher on ERDAS Imagine. ERDAS Imagine is a geospatial authoring system that allows us to turn our geospatial data into actionable information. We can process optical imagery, radar imagery, hyperspectral imagery, elevation data, LiDAR data, vector data, and so forth. Indices is just one part of the analytics in ERDAS Imagine, and they're used extensively through many applications such as mineral mapping, vegetation analysis, soil analysis, and water mapping, to name a few. And the power of indices is they help bring out the subtle differences in imagery that may not be so obvious when you're just doing classification type workflows. So let's take a look at what exactly indices are. Indices are used to create an output raster data, basically a thematic data set, and it uses mathematics to combine digital numbers or DN values from different bands within the image data. A simple example may be band X, the value from band X minus the value from band Y. Somewhat complex could be something like a normalized difference indices. We have band X minus band Y. We take that difference and divide it by the sum of band X plus band Y. And then there's more complex examples of indices. One of the basic applications of indices are for ratio images. And ratio images are derived from absorption and reflective spectra of the material of interest. The absorption is based on the molecular bonds of the surface material. Therefore, the band ratio often gives information about the chemical composition of that target feature. And ratioing is simply band X divided by band Y. Now, this basic functionality exists in ERDAS Imagine through the graphic user interface, but we can extend the functionality of these indices through spatial modeling. And kind of the process to do that is we simply select the indices we want to work with from Imagine. We can view the spatial model that's behind that function. Every indices has basically a spatial model. The functionality is captured in a spatial model. And then, since we don't have to create that spatial model from scratch, we have a good starting point to kind of go down a specific use case or a specific workflow for a specific customer need or a need of a colleague or coworker. So with that, I want to go ahead and jump into the demo today. All right, we have ERDAS Imagine, and I have a NAPE image data set here. NAPE is very readily available. It's very easy for people to get access to NAPE, so I think it's generally a good idea to show something that consists of data that's very easy to obtain. Within ERDAS Imagine, we can specify the NAPE sensor model, the red, green, blue, near-infrared stack, and then it gives us the ability to very quickly jump between different ways to view that image. Now, as we've shown in previous webcasts, the raster tab has most of the raster analytics in ERDAS Imagine. The indices are found underneath the unsupervised menu, and we can select the indices that we want to work with through this graphic user interface. Now, Imagine's good with recognizing the image data set we want to work with. The very first thing we'd want to do is specify the sensor model. In this case, we're working with a red, green, blue, near-infrared band stack. The next thing that we do is we want to either select the category. We have several different categories, or we can just select the indices we want to from the drop-down list. Now, this drop-down list is dependent on how many bands of imagery or how many bands of data you have within your image. You can click on Show All and see all the available indices to you. But once you have your indices selected, you see the formula. In this case, we have our friend Normalized Difference Vegetation Index. It's simply the near-infrared minus the red divided by the near infrared plus the red. If we look at another indices such as ferric oxide composition, that is simply the visible red divided by the visible green. A few other examples, iron oxide, visible red divided by visible blue, and so forth. One of the things we can do is we can very quickly preview an example of what the data set would look like. And then the other thing that we'll show later today is how to look at the spatial model that's behind the indices we want to work with. Going back to our graphic user interface. So if we want to just calculate an indices from the graphic user interface, we would simply go to our output options, and we have several options here. Typically, for a normalized difference indices, we want to keep it as a floating point default so we can work with the full dynamic range of possible values and also accommodate pixel values or decimal values or decimal places. And then the other option we have is to stretch it to an unsigned 8-bit. Maybe we're not really concerned about the real values. We just want to work with a color table and so forth. So we have those options, and we simply specify the name and output that file. Now, what that would look like is something like a grayscale image like this. One of the neat things about displaying it as a pseudo color, I can open up the attribute table, redock it to the other side of my Imagine viewer. I can zoom in, and now when I click in my data, in my indices image, you can see that it selects the corresponding row that I click on in the viewer. Another neat thing is I can left click and drag through this image, and I'm focusing on an agricultural field here, and it will select all the range of values that my pointer interacted with. And this gives us some nice functionality in that I can select my color column, select colors, and I can color all the pixel values that I selected with my pointer. So in this case, we can zoom in and we can very quickly see the differences in vegetation health in this case. So we have magenta pixels that are relatively less healthy than what our green, yellow, orange, and red pixels may show. So that's one way to work with indices in ERDAS Imagine. Another way is to go to File, Open, and we can open the indices as an image chain. So I go ahead and do that. And what the image chain does for us, it allows the user to very quickly change between data types. So by default, it displays as panchromatic. If I want to change that and maybe work with the color table, I can choose pseudo color. And I can work with the color table that's readily available to me. And all I can do is select it, and I can hover over the color that I want or the color table that I want. I can scroll down. So there's a long list of color table options, and in this case, I'll go ahead and select my healthy color table. We can look also at the stretch panel. We can show the original histogram and see how it's been stretched. I can do inversion of the histogram. We can zoom in. In this case, I have a display where my vegetation is green. My healthy vegetation is green. The non-vegetated features are actually red or orange or yellow. So that's a way to display your vegetation indices using the image chain. In the same way, I may want to calculate a surface water indices using the surface water indices in ERDAS Imagine. And you can see here we have yellow polygons that represent our water bodies. And I can invert these, and I can remove the yellow polygons, and now I have blue polygons. So there's different ways to manipulate the values in our indices to get the color ramping that we want to obtain. All right, so the next example is I have a spatial model here, and what I've shown is the ability to quickly view an indices as a spatial model. So in this case, I'm doing something kind of creative. I'm taking my vegetation indices in the spatial model. I'm calculating vegetation indices. I'm also calculating the surface water indices, and I'm going to combine that with the original bands from the imagery. And this helps kind of bring out the subtle differences that we may not be able to quickly see in the image. And what that looks like So I'll open up my Indices image stack. And this is an 8-band stack, and I'll explain what bands are included. So by default, it displays the same as the color infrared display. Now, since I've calculated water indices and vegetation indices and a few other indices, which I'll mention here soon, I may want to bring the water indices and run this through my blue color gun. And you can see very quickly that the water features show up as bright blue compared to what they may look like in the original image, which is pretty dark, and we can kind of lose those features sometime. So now I have my blue water indices running through the blue color gun. I may want to take my NDVI, which is my layer number 8, and run that through the red color gun. And we can start to see we have healthy vegetation as being bright red. Now, if I want to try to look at the subtle differences between my vegetation types, I can select in my green color gun the near infrared band, which is my layer number 7. And now very quickly I can see I have orange tree canopy, I have yellow healthy vegetation, and kind of a dull green grass vegetation. So this gives us a way to see the very subtle differences within vegetation and water. Another example is I have a couple iron-related indices in this band stack. So if I select band 4, which is an iron oxide indices, I can start to zoom in and see subtle differences within the soils and within the ground. If we compare what this looks like to the original image, yeah, I can see some bare earth and some differences, but it doesn't jump out like it does when you combine your indices back with your original image. So that's an example of creating just 2 simple indices, or in this case 3 simple indices, and stacking it back in with the image data. So let's take a look at some customization. I want to go ahead and remove this from my Spatial Model Editor and open up a vegetation indices. This is an indices that we looked at in the Watch Bucket Automation webcast that we presented on October 6th. If you haven't seen that, please go to the Hexagon Geospatial website and you can see the recording. What we've done here is we have our input raster. The main core functionality of the indices is held right here. So when we select the indices and view that functionality, this is the operators, the spatial modeling operators that we see. Now we may have an end user, a customer, who wants to break up their NDVI indices into multiple classes. So we've provided a few ranges. And the way you find these operators in the spatial model is you just simply type in the name of the operators, you find it, you drag it into the canvas. And in this case, the range operator is looking for a start value and an end value. So in this particular spatial model, we have identified 4 ranges, which will be used to create a 4-class NDVI. So we have our ranges selected, we have our output. Now the spatial model will select those values from the data, create a 4-band thematic data set, give it a nice color table, attach in this case, vegetation classes to those color tables, and the result looks something like this, where we have color-coded thematic agricultural data. So in this case, I can turn them on and off, and you can see the subtle differences. So in this particular field, we have the yellow pixels represent somewhat healthy vegetation compared to the dark green pixels. Another example is up here in this field, you can see there's some orange, what would be considered maybe unhealthy, and how they are in context or geographically related to the yellow pixels, which are somewhat healthy, and then the green pixels. So you have a way to take a simple imagined indices and customize it to your specific need. So we take a look at another example. This is something that we've shown in a previous webcast as well. This is our Pool Finder spatial model. And we showed this webcast on May 5th, and we showed how to publish this to a server environment. But the same general thing, we've extracted our indices from the graphic user interface. in Imagine, and then we're customizing it to meet a specific need. So in this case, here is our image input. We're taking our near-infrared band and our green band to do our water indices, and we're even adding some more customization by removing the potential of false positives related to shadowing. So we can specify a shadow threshold, and then once the spatial model has calculated the values, we are selecting a water threshold, so we have a greater than sign, and then that flow goes up to another filter, and this filter is a minimum and maximum area filter. Maybe we're looking for water bodies of a certain area. So once we run this filter, then we simply convert it to a polygon data set. We calculate a couple attributes. In this case, we're calculating area and perimeter. And then even more creatively, we're using those new attributes we've just calculated to calculate a third attribute called compactness. And then we're filtering against compactness because we're not interested in elongated water bodies. We only want oval and round-shaped water bodies in this case. And this outputs to a polygon data set. And this is a shapefile, and we have nice blue polygons that were extracted directly from the NAPE imagery. So those are two examples of customizing existing functionality, existing indices in ERDAS Imagine. So the next application I want to look at is fire. Let me close a few windows here. So here we have a Landsat scene, and this is an area outside of Austin, Texas. We have a watershed here that was first affected by a fire and then affected by a flood. So the debris from the fire made it into the flood channel and created a lot of havoc in the general vicinity of this community right here. So in ERDAS Imagine, this is another indices we can calculate to extract the burn area. So again, we go up under the raster tab, we select indices, and from the drop-down menu, we have this normalized burn ratio. And this is looking at the near-infrared and the short-wave infrared just beyond the near-infrared wavelength. And the formula here is a normalized different formula. And when we run the output, it looks something like this. It's another grayscale data set that we can work with. We can view that as in our image chain as well and get our color ramping. In this case, I want to select the area that is affected by the fire. So we display the attribute table again. Whoops. And then I can click in the image, and it selects the corresponding value in the, whoops, wrong one, sorry. It selects the corresponding value in the raster attribute table, and we can do the same general thing. I can drag through here, and it selects that range of values, and then I can color code those. And then I can do a neat thing like the inverse selection, select my opacity, select the formula, and make all the other values transparent. And then when I zoom out, I can see the full range of the burn of the fire and even other areas that I maybe didn't expect to see. So that's a way to extract the burn area from a fire using Landsat and ERDAS Imagine the burn ratio. Now, if we want to take a closer look at this specific watershed, we can always go back to our NAPE imagery. Here I have a before image, NAPE data set. I have an after image after the fire event. You can see the vegetation that was affected by the fire. If I bring a couple, let me just close this window here. So in this case, I'm bringing in two NDVIs. I have the NDVI of the before image. I have the NDVI of the after image. I'm simply doing a subtraction, and it's going to give me the resulting pixels based on a criteria based on the value of the change. And what that would look like is a thematic data set where I have these magenta pixels that represent the burn area. And again, we can interrogate the raster attribute table. We can calculate the total area. If I look at the table functions, we have add area. And then once I have the area calculated, I can go to compute stats and get the total area of the fire burn. So this, in this case, the fire affected 1.41 square miles of this area. All right, so that's the example of fire. Now I'm going to go back to the pool finder indices. And again, this is something we've showed with the ERDAS Apollo and how to publish this to as a web processing service. So once you have a specific use case or specific data output from a customized indices that you've created in ERDAS Imagine, there's a couple different things you can do with this to extend it further. Maybe we want to share it with our colleagues or with our end users, or maybe we have customers that could benefit from this. So straight out of ERDAS Imagine, there's a couple ways to do this. We can publish this spatial model. In this case, it's basically a spatial recipe. We can publish this spatial recipe as a web processing service to ERDAS Apollo. The other thing we can do is publish it to the Hexagon Smart Map platform, or basically cloudifying the spatial recipe. So I have a surface water function that my customers and my end users and my colleagues can run from basically a web environment. And what that looks like is we go to our Hexagon Geospatial Smart Maps page. I would simply sign in. And once I'm signed in, when you publish this and you create a template around it, you can build a nice smart map application that is now cloudified. So every one of these, well, pretty much all of these, the green space analyzer, the vegetation health indices, the change detection, was once a spatial model. So if I select my pool finder, it presents me with the same input, but now I'm on the cloud. I'm in a web portal. I can input my data. I can specify the parameters, and then I get the same functionality that I would get on the desktop. In this case, I have nice magenta water bodies, and we've actually been able to extract pools, swimming pools, within a neighborhood. And we can turn off the image and see how it would affect our GIS. If I brought in some parcel data, you know, I can get a good sense of how many swimming pools are in a certain community and so forth. And so that is the Hexagon Smart Maps platform. So just in summary, we showed the indices in ERDAS Imagine, how to select those and how to adjust the outputs. We can display the indice results in both kind of a pseudo color and an image chain fashion. And then we can view the model of each indices. Based on which indices we want to use, we can view that model in a spatial modeling environment and then also modify that model to our specific need. And then it becomes basically a spatial recipe. And then we have the ability to publish that spatial recipe to a Smart Maps environment or to a server environment with ERDAS Apollo. So thanks for attending today. That's the end of the demonstration. I'm going to go ahead and turn things over to Lauren Wood. Lauren?
Thanks, Frank. Great job. Now that you guys have learned about customized indices using ERDAS Imagine and Spatial Modeler, we have some polling questions that we hope you guys will participate in. These should be showing up on the right-hand side of your screen. So the first question you should see is, do you use multispectral imagery? And you can select yes, no, or sometimes. The second question you should see is, are indices applicable to your project work? And you can select the same answers as above, yes, no, or sometimes. And the third question is, does the ability to extend ERDAS Imagine indices to a cloud environment interest you? And you should be able to select yes, no, maybe, or not sure. And be sure to hit the submit button in the lower right-hand corner once you're done answering these questions. A little bit about our e-training. We have an extensive list of e-training and demonstration videos online with all of our products, so we encourage you to look into this. Going into e-training a little bit more, these are free self-paced web training on different topics at no cost to you. So we've put the link at the bottom of this slide, and we encourage you guys to look into this more. We also have all of our previous webcast recordings available for you to view on our website. Our current schedule, we only have 2 left for the 2016 year, so we encourage you guys to register for these if you're interested. Our next one will be in 2 weeks on December 1st, and it's What's New in ERDAS Apollo 2016. We also have a few other polling questions for you guys. We're always interested in learning about what topics you'd like to see covered in our webcast series, as well as if you're interested in pricing information for Hexagon Geospatial products. So if you guys can answer these questions as well, and then be sure to hit the submit button in the lower right-hand side of your screen. We're going to go ahead and jump into the Q&A portion of the webcast. So the first question that I see that's come in is, what level of ERDAS Imagine is required?
Okay. So there's a couple answers to this. So if you want to create the spatial modeling or customize the indices, it's Imagine Professional. Now, if you just want to run the indices, you can do that simply with Imagine Advantage.
Great, thanks, Frank. Another question I'm seeing is, are the indices for world view satellite imagery in Imagine?
Yeah, so if I had a WorldView 2 or 3 data set and displayed in Imagine, and from the drop-down menu when I identify my sensor model, I would choose that sensor, and then there are actually WorldView specific indices that we can use and customize in the very same way that I showed with the examples today.
Great, thanks. We have time for one more question. So the last one that I see that's come in is, band stacking of indices is very interesting. Is it possible to combine raster analytical functions such as classification or principal components with the indices in Spatial Modeler?
Yes, good question. Yeah, so in the same way that we create the indices and kind of the example I showed with stacking with the original bands of the image, you can chain other analytical processes together as well. So if you have something like principal components, unsupervised, image segmentation, it's very easy to connect those functions in a spatial model or spatial recipe in that case. Yes, thanks.
Thanks. Well, we are out of time, so we appreciate you guys taking the time today to attend this webcast. I see a few other questions that have come in, and we'll be sure to get to these offline. We also have contact information up on the screen, so feel free to reach out to us if you need any additional information. Thanks again for joining us, and we look forward to seeing you on our future webcasts.